First, we have the ramp, and we had to measure the length of the ramp, and then in this case we get 25.5 centimeters, and we could convert that into 0.255 meters. So after you measure the length of the ramp, you have to record how much time it takes for the truck to go down the ramp. In my case, it took 0.4 seconds for the truck to go down the ramp. You need to use the equation d equals to vi, which is initial velocity plus final velocity vf divided by 2, and then times time. And then I plugged in all my values. This is my distance of the ramp, which is also the length. This is my second, and this is the equation. So after I plugged in everything, I get that VF equals to 1.275 meters per second. So now I have this part of my problem done. This is only part 1. So we have to go to part 2. We have to figure out what flight time is. So now you can solve for flight time. You have to use this equation, dy, which is the vertical direction. Dy equals to initial velocity times time plus half of acceleration times time squared. So in this case, our vertical direction, since we only care about the vertical direction since it's moving down, it's falling, so we don't care about the horizontal. So I get that dy is 0.91, and then since initial velocity is 0, then we could just cross this out. So we have half at squared. So we plug in all the values, we get what this is, and we try to solve for t. And t is time, so we're getting how long it stays in the air. So after we plug in our values, this is our acceleration due to gravity. This is the y direction, and this is the half. And we square root it to cancel out this. We get that equals to 0.43. Time equals to 0.43 seconds. Now after we have this, we need to know where it will land. So we have to look at the horizontal distance, so we can make sure that it will hit 100%. So we have to use. So you already have both variables, and you can solve for d. So we have the final velocity, and we also have the time. So as long as we have these two, we could just multiply it, and dx will equal to 0.55 meters, or if you convert it, you'll get 55 centimeters, and that's how far it will travel. So by concluding this, we could set our target, our 100%, 0.55 meters away from the ramp, and this way the truck will always land on 100% every single time.